Now by the word standard parabola, we mean that the parabola is positioned in such a way that at its vertex it touches the x-axis or y-axis. So in this case we are going to study the first standard orientation of the parabola as shown here. The yellow colored curve is nothing but the parabola. We can see that at its like tip, that's the vertex, what we call it, it's at origin, and the point S is nothing but the focus of the parabola, right? Now let us first consider the coordinates of the focus to be equal to say a comma 0, where a is the distance of the focus on x-axis. That's why it is its x coordinate. Now since we know that if you observe the point O, that's the origin, that itself lies on the parabola as well. So therefore its distance from the focus must be equal to its distance from the directrix. So that means the directrix also must be at distance a behind the origin. That means the equation of the directrix will be nothing but x equal to minus a. Right? So we have this important information available with us. Now to find the equation of a parabola, or rather equation of any curve, what it means is, if you assume some general point, say x comma y, on that curve, in this case parabola, then what is the relation between those x and y coordinates? So that relation which is satisfied by each and every point on that curve is nothing but the equation of that curve. So here if we call the coordinates of point P as x and y, we are trying to find out what's the relation between x and y. For that, let us understand the definition of parabola as we have seen. Like it's a curve in which the eccentricity is 1, or what it means is its distance from the focus and its distance from the directrix, okay, both of these are same. So that point P is equidistant from focus and directrix, right? Let us call the foot of perpendicular as m, as shown here. Now the equation of directrix can be written in standard form, which is x plus a equal to 0, right? Now to derive it, we start off with the known condition that SP has to be equal to PM, isn't it? Now SP we write with the help of distance formula, that is x minus a the whole square plus y minus 0 the whole square is equal to PM is the distance of point P from the line, straight line, x plus a equal to 0. So we know the formula for that, that is nothing but x plus, since y term is not there, we don't write anything for y, and the constant term a divided by square root of 1 square plus 0 square, right? We square the coefficients of x and y in the equation of the line and add them. Now here we see the roots on both sides as well as the modulus sign, so therefore we will square both sides, and on squaring we will get x minus a the whole square plus y square is equal to x plus a the whole square, and the denominator is 1 because it is root 1. Alright, so now let us expand the bracket, so we get x square minus 2ax plus a square plus y square equal to x square plus 2ax plus a square. So we see that x square term gets cancelled and so is the a square term, and taking minus 2ax on other side and merging, we get the final equation as y square is equal to 4ax. So this is what is the equation of the standard parabola shown in the configuration as shown in the figure. So it's like we call it as the parabola opening on right side, that's the standard parabola. Now similar to this, there can be a parabola which is the reflection of this shown parabola, that is a parabola opening towards left, or there might be parabola opening upwards or downwards. So that gives us basically the 4 fundamental standard configurations of parabola, and for each of them we will derive or like list down the different parameters associated with the parabola.